All right, guys, we are going to take notes. If you've already done notes from the Explore activity, so like if you're on red track, you can continue your notes from that page. If you are on white track, you did the Explore activity in class. If you want to add to your notes from that day, that would be fine. But either way, go ahead and write on the top, identifying proportional relationships. So, I have already taught you, and I will remind you, one way to tell if something's proportional. And that is take the table of all your data and divide y's over x's. And when you do that, if you get the same number in every situation, then it's proportional. All right? Well, there's a whole nother piece of proportionality that we need to look at. And it's going to help kind of tie all of this that we've been learning together. So let's kind of remember the format we write our equations in are y equals kx. K is your constant, also called constant of proportionality. Remember, I can't spell. I put the R in the wrong spot. Sorry. Proportionality. So in this equation, the k is going to be replaced with a number. And that number is what we're multiplying the x by to get the y. All right? So let's pretend that there's a house cleaning company. And they charge for 1 hour, 45 minutes. For 2 hours, 90 minutes. For 3 hours, 135. They skip the 4. And for 5 hours, 225. That's an ugly 2. Okay? And so we know the top, and because it's time, is x. And we know the bottom is y because it's total cost. All right? So the first thing we could do to tell if it's proportional is 45 divided by 1. Remember, y's over x's. 90 divided by 2, 135 divided by 3. We're obviously missing a number here, but 225 divided by 5. If we get the same exact number, what we have found is our k, our constant of proportionality. Another way to ask yourself is, what did I do to my x to get my y? I multiplied by 45. I multiplied by 45. So we know that this equation is y equals 45x. Let's add to this information. So, I'm going to tell you right now, and it'll make sense once you start seeing me do the problem. Okay, but write this down and I'll repeat it, so if you need to rewind me. If the graph crosses at the origin, 0, 0, it is proportional. I'm going to say it again, so write this down. If the graph crosses at the origin, which is 0, 0, it is proportional. So, we need to know, does this graph give us a 0, 0 at when x is 0, y is 0 situation? Okay? So I'm going to show you a way to tell. Let's look at our constant here. This is plus 45. This is plus 45. This is plus 45. We just didn't, okay, and then this, and we could check it, is plus 45. This is plus 1. Plus 1, plus 1, plus 1. So we see this constant relationship. So what we can do is we can take this relationship and extend it backwards to see if x is 0, is y 0 also? And if it is, then this graph is proportional. So to go backwards, I could minus 1 and I could minus 45. Because that's the opposite of this pattern. So 1 minus 1 is 0. 45 minus 45 is 0. So yes, this graph is proportional. And if you wrote 1, 45, 2, 90, 3, 135, like as data points, like actual ordered pairs, and you graphed them, your line would cross at 0, 0. Okay, so that's how we figured out with numbers. Let's talk about what that means. What is 0, 0? So let's come back to what this relationship is. This relationship is how much time a house cleaning company is working for me and how much money I'm paying them. So if they work for me for 5 hours, I'm going to pay them $225. If they work for me for 1 hour, I'm going to pay them $45. Do you think if they work for me for 0 hours that I'm going to give them any money? No. That 0, 0. Because if you don't work for me at all, I'm not going to give you any money. That's the way it works. So that would be not having a starting amount. And I want you to write that, and then I'm going to explain that more in a second. So this is no starting amount. Because at 0 time, I've paid $0. Okay, 0 time, I've paid $0. So let me talk about some situations that do have starting amounts and would not be proportional. When I go to the gym, I have to pay a gym membership before I even go use their machines. So at 0 time at the gym, I've already spent money. That's a starting amount. That's not proportional. Here's another one. When I go bowling, when I walk into that bowling alley, I have to rent shoes before I get to go play games. So at 0 time bowling, I've already spent $2, $3 on renting shoes. That's a starting amount. That's not proportional. And then here's one I really want you to think about. You had a problem the other day where someone was giving out coupons, okay? In the situation, there's one part of the situation that just said they gave out 52 coupons every day. So at day 0, they gave 0 coupons. That's proportional. There was a second situation where the first day she gave 416 coupons. And then day 1, she gave out 52. And then another 52. So at time 0, before all of our add 52 came in, at time 0, this woman had already given out 416 coupons. That's a starting amount. That's going to make the rest of the data non-proportional. Okay? So there are a lot of things that do not have starting amounts. Gallons in a bathtub. At 0 time, I have 0 gallons in there because I haven't turned the water on. Versus maybe a situation where they say, you walked in, the bathtub was already partly filled, and now we're going to keep filling it up. Okay, at 0 time, there was water. That's not proportional. Okay, so hopefully this is kind of making sense. So to decide if it goes through 0, 0, you could graph the whole equation, which would definitely be a great way, and then continue that line out and see if it goes through the origin. Or you could use the pattern of your constants to work backwards and see what happens when x is 0. Think about it. X is time, so you can always get to time 0. If you get to time 0 and there's a value on the y, you know it's not proportional. All right? So let's look at some more examples. Okay. So I'm doing the Your Turn on page 130 if you want to follow along with me. Okay? So it says Jared rents, oh look, bowling shoes for $6. So bowling shoes for $6 and pays $5 per bowling game. Okay, so we see this per amount. That's our 5x. Okay, every time we see a per, we connect it to an x. So that's our 5x. If the situation was just that we're paying $5 per bowling and we brought our own shoes, this would be proportional. But what did we have to pay at 0 time? We had to pay those $6, so it's not proportional. And then I'm going to prove it to you with the numbers. So at 0 time, I've already spent $6. Then after 1 game, okay, so 0 games, sorry, not time. Sometimes it's time, sometimes it's games, you got to kind of like look at the problem. So, games and money. So 0 games, we spent $6 because we had to rent the bowling shoes, which are so cute to wear and so fashionable. If you've never been bowling, right now, Google bowling shoes and you will see the sarcasm that's coming out, okay? So at one game, we've paid the 6 and the 5, so that's 11. At 2 games, we've paid another 5, which is 16. Okay, and you can already see 11 divided by 1 is 11, and 16 divided by 2 is 8. This is not proportional. Because at 0 games, we've already spent $6. This is a starting amount. This is our per amount, and because we have both, it's not proportional. Now, if everything I've said makes sense to you, that's awesome. That's what you need to know. I'm going to add one more little 8th grade thing, so just in case you get it. If we did not spend the $6 on shoes, our equation is y equals 5x, because this is our k. I take the x, I multiply by 5. But because we spent $6 on shoes, we're going to add a 6 to that equation. And you can see this is because we had to add this 6, even though it's a one-time amount, it's a one-time event, a starting amount, it makes this whole thing not proportional. So when you see an equation like this, it's proportional. As soon as you see this number out here, that's your starting amount, you know it's not proportional. And we're going to learn later how to graph these. It's really nothing harder than just normal graphing. But I want you to see this because this is the equation that goes with this. I started with 6, then I do 5 per game. Okay? All right, I think my time on this video is up. I'm going to start a new video. We have one more little page of notes, couple more practice problems. I really think this requires that extra time, so make sure you watch, and I will see you in a second.